Hi guys, and welcome to HSC Chemistry and the acidic environment video series. In the last little section that we're going to do in section 4 of the acidic environment is just the cleaning up of spills. So this is kind of just like an aspect of the application of our understanding of neutralization reactions to what sort of things can happen in the science laboratory. So first of all, we need to observe certain safety procedures. There's a little quick question on which word was incorrectly spelled on the titles. Understanding safety procedures in the laboratory involves the use of neutralization reactions when spills can and sometimes do happen, particularly in the case of some of the corrosive acids and bases. So these are ones that are strong acids and bases, often in high concentration as well. These ones need to be neutralized very quickly if they're spilt, apart from the fact that they can have quite a devastating effect on furniture or other kinds of materials around them. They can also cause a little bit of damage to humans as well. So what we want to try and do is look at some of the ways in which we can neutralize these acids and bases very quickly, how we need to dispose of each of these different types of acids and bases into common waterways and sewage treatments down the sink basically, and what sort of substances we choose for cleaning up those spills. So the most common one that we choose is sodium carbonate or sodium bicarbonate. And one of the reasons for this is its ability to neutralize both acids and bases, and the fact that it is itself a weak base. So one of the important things about sodium carbonate is it's stable, it's a solid, and it's also a primary standard. So we know whatever we use, we can be fairly sure that that's not going to be reacting in the environment, it's not going to be changing its pH and doing all of those sorts of problems. It's safe to store and safe to handle, it's readily available, and it's very good for neutralizing acids. So obviously, being a weak base, we can put a large amount of that in to neutralize even a strong acid and return that pH back to 7. What's very important is if we go overboard and just throw a whole heap of this particular substance in because we're not sure how much acid is there or how what its concentration is, then if we use this in excess, it doesn't matter. It's a very safe chemical to choose and use, and it will do the neutralization job without leaving any corrosive residues behind. When we're cleaning up bases, well, we use effectively the conjugate acid of the carbonate ion. So in this case, the bicarbonate ion. So we know that the HCO3- ion can act as both an acid or a base, according to the Bronsted-Lowry definition. And so it's a good one to use for the neutralization of acids, but can also be used for neutralizing basic solutions. It's again very safe for storage and handling. It's very stable. Again, it's not going to be a problem if it's used in excess, as we talked about previously, and it has the advantage of neutralizing both low concentration or weak acids as well as basic solutions. This amphiprotic nature of the bicarbonate ion makes it an ideal one to choose for acid or basic spills, even though for the strong acids we tend to use still, as I mentioned before, the sodium carbonate ion. So the important thing to consider when you're looking at selecting an agent for neutralization is, firstly, we want the reaction to occur rapidly. We want that neutralization to occur quickly so that the damage is limited. We want the consequences of the excess of our neutralizing agent to be safe. So if we put too much of that on in order to try and neutralize our spill, then we know that that excess is not going to react with our metallic furniture or anything else, and certainly not going to be a danger to humans, because we need to make sure that we can handle it safely and store it safely. So safety and storage, two important considerations. Cost always is, and sodium carbonate, sodium bicarbonate are readily available in supermarkets often, and so they're not a huge cost, and they have a very wide breadth of use. That means we can use them to neutralize a very large range of acid and base spills. So the combination of sodium carbonate and sodium bicarbonate are two important substances that we use in the neutralization of acid spills. Thanks for watching.